All right. Hey, everyone, and welcome to this session where we will be doing a streaming super smash, whatever that means, with looking at the capabilities in Microsoft Fabric and Databricks and what they offer for using streaming data sources or event-based data sources, in other words, if you could describe it in that way. And before I kind of jump into the topic of today, I really want to say thank you to Redgate, because Redgate has made it possible to have this really lovely space and everything set up, so it has made it possible to have this lovely event today. So with that, let's get going. So if we look at the modern data platforms, we are, I think, in a really cool time because we have all these capabilities where we are able to have really powerful platforms that give us all kinds of capabilities to work with our data. Whether we're doing batch processing or more streaming approaches, we can kind of find some core capabilities that are similar in all of them. One of the most core principles that we have there is that we have to have the storage and compute separated so that those can scale independently. And a lot of times we actually have like a storage layer, and on top of that, some kind of metastore that then makes sense of the files that are stored in the storage, so they look like an actual database table. And then we have all kinds of flavors of compute, as well as some orchestration capabilities on those platforms as well. If we look at this from the perspective of Databricks a little bit, on the storage layer, we have Azure Data Lake. When you are running Databricks in Azure, of course, if you're using the other clouds, it's a slightly different architecture. Then in Databricks, we have something called Unity Catalog. And on the compute layer, we have some Spark Databricks clusters, as well as SQL warehouses, and then workflows for the orchestration. This is a very, very quick run through. Don't worry about that. We will come back to this much later in more detail. On the Fabric side, we have one lake, which is essentially Azure Data Lake packaged all nicely together. We have several kinds of metastore layers, lakehouses and warehouses. Depending on which one you use, you have Spark Compute available for lakehouses and warehouse capacity for warehouses. Warehouse capacity doesn't really say much, but it's a SQL-based engine in like a parallel fashion, again, where we have the compute and storage separated, as well as then we have pipelines, as well as data flows to choose from for orchestration. But if we look at the streaming side, we have kind of another dimension. We have event houses, which leverages the Kusto engine, and then we have event streams to be able to ingest data and transform it on the way. So why am I starting from here? Well, we kind of get the idea that there's a lot of these bits and pieces in these platforms to choose from, and depending what your aim is, you would use different components. And if we look at streaming specifically, it can even be a little bit difficult to know like which capabilities should we use, because there's a few different things that you could leverage in each of these tools. And they have a very different approach to streaming as well. So what we'll try to figure out in this session is, well, in which case should you use which? Because it does depend, as I would say as a consultant, to many, many, many questions. So we will try to figure out what does it depend on. So to do that, we will first look at like general streaming considerations. Why is streaming a little bit hard actually to do when we look at it? It's not the simplest solution to build actually. Then we'll look at what are the different capabilities for streaming for each of these platforms. And then lastly, we will look at kind of the differences for these two and where each of these, the strengths are for both of these platforms. So I'm Heini Ilmarinen. I come from Finland. I'm a Microsoft Data Platform and Azure MVP. I often like the topics where I need to figure out how the different bits and pieces fit together. So really like the architecture problems. For me, it feels like I get to solve puzzles all day, and that's kind of fun. And I have a very dark history with math. So yes, we'll not talk about that anymore. And as you might have already figured out, I'm a bit of a serial doodler. I like to figure out how things work by drawing them out. I have a lot of paper notebooks with different scribbles on them. So I just someday figured maybe I should do my slides in the same style, because it's much more enjoyable for me than making regular slides. In kind of the work side, I'm a co-founder and I would say like a data platform architect at Bruvo. We're quite a fresh company in Finland, a little bit over a year old, and doing all kinds of cool things in, for example, Databricks and Fabric, to mention some. With that, are we ready to get going? I would really love to see the chat, but I don't know if I can. Nothing in the chat. Okay. All right. Let's then just get going. Let's start with looking at general streaming considerations, because, well, processing data as it comes in isn't maybe as easy as it seems on the surface. When we think of the data sources that we might be using when we talk about streaming data or event-based data, some of those sources could be like smart transportation devices, meaning cars or buses or something similar. We could have some IoT devices that we want to draw data from. Nowadays, we have a lot of wearable devices that produce data all the time. Also, if we think about all the applications we use on our smartphones, etc., those also produce data. As well as then we have more traditional databases as well, and it's a possibility to also get data from there as through change data capture. So only capture kind of the event of what has happened in the database. If we are aiming to then draw that data in real time and have it on our platform and be able to then process it and have some kind of end result that would then bring us some kind of value, we need to have capabilities that support us to do that. We have to be able to ingest the data just as it is produced, as with little delay as possible. We need to be able to process each event as they come in, and then we would need to have some kind of serving layer that is able to produce the result as soon as possible again. So if we think about all of these data sources that we might have, they produce different kinds of data for us. We need to think about what kind of service we need for ingestion. There are all kinds of different options there. In Azure, we have, for example, event hubs. We have also Event Grid. If you're working with IoT devices, you might look into IoT Hub, etc. But there's also a lot of kind of general sources that could be used, or ingestion methods actually. So Kafka is something that is leveraged quite widely, but something one could use is also MQTT. And what is common for all of these is that they take in data, they kind of have it in a queue type of stream, and then a processor is able to pick up that data and process it as it goes on. So then as we take the data in, we have the option of doing like code-based processing on that data. Some services also provide us to do more of that click and drag type of processing that makes it easier to develop. And then if we think about the serving side, it could be that we are relaying this data onwards to another kind of database or data structure, or we could be providing an API. And then we could, of course, also want to have some kind of report in place where we want to visualize this data. Some other options is, of course, also having some kind of alert based off of that data or something similar. So depending on what we want to do. Some of the use cases could be that we want to get alerts on deviations from our the average range of data that we have, or we want to have that real-time visibility to how our devices look that the data is originally coming from. But with this kind of pattern, there are actually some challenges that we need to address. And some of the core things that we come across when we start to do streaming is, first of all, what if some data comes in? The point of real time is that, well, we get the data as soon as possible, but as close to the time it was actually produced. So what if it happens that we have data coming in, like after the fact? it comes in like 5 minutes later than it was produced. It does happen, and we have to think like, how long do we wait for that data and how long do we actually keep processing it if it arrives a little bit later. Then the second challenge we have is checkpointing. So this has to do with the aspect that when we have that ingestion point and then we are processing it on from there, how do we know how far have we read that stream? So we need to have knowledge of which events have we read from this particular stream that we are reading. Then we have to think about handling duplicates, because sometimes our data producer might just send another message event that is the same as another one. So how do we handle that again? And what if that form of that data set changes completely that is sent to us? Because unfortunately that happens as well, especially with devices. You know, we often get the data in like a JSON format or something similar, and that is quite a flexible format where we could be like, with some like additional capabilities on our device, we could suddenly start sending new data, for example. So we also need to be able to handle what if that schema changes. Another dimension we need to look at is, well, do we need real time or do we just need near real time? Because there's kind of this scale. The closer we go to real time, the more challenging addressing all of these issues is. The closer we are just like near real time, maybe like a minute, 2 minutes, the easier those are to handle. But as the closer we go to like, yes, it has to happen right away when the data is produced, the more challenging all of this gets, and also oftentimes the more pricey it is going to get. So we really need to evaluate what do we mean with real time. And that I've noticed it differs in like all organizations I talk with. For others, it means, well, it should happen in a second. For somebody else, it's like, half a minute is fine. So we need to also check what does that actually mean for us. The more complex processing we need to do on kind of on the way of actually producing that end result, the harder it is, of course, to get to that very, very real time, and the closer we have to take the processing to the actual producer of the data itself. So there are these kinds of issues as well. Today we will focus on the patterns where we are ingesting that data to some platform. As you might imagine from the title of the session, we will be looking at Databricks and Fabric specifically. So with that, we have covered kind of the general streaming considerations we have to take into account. And that means that next we can look at the actual capabilities that both of these platforms provide for us that can help us with streaming. And we will maybe see where it might be a little bit easier and where we have a little bit more control for our data. So we'll start from the Databricks side today. And well, Databricks is based on Spark, and within Spark we have this capability called structured streaming. And structured streaming has, well, it is meant for streaming specifically. So it has a lot of support for the challenges of streaming that we talked about in the very beginning. How Databricks works in general also is that you create a notebook where you have your specific code that you want to run. Behind the scenes, you need a cluster that has that compute power that you need to run that processing. So it would be a Databricks cluster that you are running. And then since we are talking about structured streaming, we need to connect to some kind of data source. In this context, we use the read stream syntax to read it from a streaming data source. And there are different sources that are supported. So we can read from Kafka, but we could also read a cloud storage location as a stream, meaning then it will track when a file is changed in the location that we are reading from. We can also read from another table in the Databricks context as a stream as well. So we have a lot of options of what kind of sources can we use there. Within Databricks, we of course then want to write that data into a table, and there's again like a write stream command that does it. And in the Databricks context nowadays, we have this metastore layer of the Unity catalog. It does a lot of other things as well than just being a metastore, but one of the aspects of Unity catalog is that we have these organization-wide structures that we create. There's this metastore layer, which is per region that you might have operations in. Then you have catalogs under this metastore, and then schemas under those catalogs, and then that table is located under there. That means that within our workspace, if we are linked to that specific metastore, then we can always reference any table that you can find from this Unity catalog structure. We can reference it in our notebooks, whether we are using PySpark or SQL or Scala or whatever our preferred language is. So it makes very easy to reference any of the tables, read from one, write to another one, etc., because we have this three-level syntax that we can use to do that. If we look at this before that, if we want to schedule our notebook that has this logic for running the structured streaming, the way to do that would be to create a workflow, and you would create a job workflow where you then reference that, hey, run this notebook, and then you could have that running continuously if you want that real-time approach. But with structured streaming, you can also specify that, hey, I run this at a schedule every 15 minutes, and I specify that I always read whatever data is available at that time. What is the new data? And then I'm able to run that kind of as these micro batches, I would say. You don't have to read the whole source, but you always only read the new data that has come in. I find that pattern actually quite powerful as well if you're not going to the very, like, hey, it has to happen right away approach. The Unity catalog looks something like this. In a real organization, it is a little bit more complex, but you get to have your catalogs listed that you have access to. And if somebody has been using the more in the past Hive Metastore that was in use in Databricks, if you upgrade to using Unity catalog, it will still show as kind of one of these sub-catalogs within Unity catalog. So that is also one path for migration, to just enable Unity catalog and then do the data movement that is required. But the Unity catalog is very much the central place to find all your data in your organization, as long as the catalog is linked to the workspace that you are working with. You will be able to see that from one place, all the data in your organization. If we look at the code a little more specifically for structured streaming, it will look like this. This sample is with Kafka, so it is you specify read stream, and then you specify which format is the source. In this case, Kafka. It could be cloud files. There's other options there as well. Depending what the format is, then the next options depend on that. So for Kafka, you need to specify what are the servers that Kafka is hosted on. Then you tell it which topic are you subscribing from, and then you tell which offset do you start with. Like, do you start from the earliest, so you read everything that is available in that particular topic in Kafka, or do you just start reading from the moment that you start this reading? Then you have this write stream portion, and this is actually where the checkpointing is done. So this is what tracks how far have you read that stream. So it means that it is actually like the writer that tracks how far have I processed the data, not the reader, which makes sense, because if you just had the checkpointing in the reading, then if something goes wrong in the processing, well, then your checkpoint is in the wrong point. So the checkpoint location that tracks how far have you read the data. You can specify a path for where the data is stored in Azure Storage behind the scenes for the table that you're writing to, and the to table option then specifies where in Unity catalog is that data stored. Like, the simple read and write is quite simple, and then you could of course do some transformations on the go as well to the data, pick specific columns. The more complex the processing is that you need to do, then of course the more delay there will be for your data to end up in the destination. So this is definitely the most performant in the cases where you are doing small transformations on the go and then appending to the next layer of your solution. For the structured streaming, we also have in Databricks really nice monitoring. So whenever a run has completed, of course, if you have a continuous stream, this will update on the fly as well. But if you are kind of running those micro batches, then you will be able to see which batch number is this. So 2230 in this case, what is the amount of rows that were new for that particular run and so forth. So this was the case where this was ran in the mode that it only reads like the new data in a small batch every few minutes. We also have another option in Databricks that we can use for kind of to ease the structured streaming pattern that we have. It used to have a really nice simple name called Delta Live Tables, but it was renamed to Lakeflow Declarative Pipelines, which is I think it's a more complex name and hard to remember, in my opinion. Too many words. Anyways, the concept kind of for the architecture itself is exactly the same as for structured streaming. You have a notebook. The notebook is just different for Lakeflow Declarative Pipelines. But otherwise, the idea is the same. You read from a source and you write to a table that is within Unity Catalog. One kind of a flavor difference that we can have here is that we can define a streaming table, and that is just a specified table which is append only and is kind of optimized for that kind of data coming in. So it is still stored, like it's still visible in Unity Catalog. The data is behind the scenes stored as Delta Live tables, but it is this append only table so that it is only then easy to also read it onwards as a stream. And the same way with the Lakeflow Declarative Pipelines, you can define it as a workflow. In the UI, it is called ETL pipelines. Like, why is it not called Lakeflow Declarative Pipelines? I'm not sure. But anyways, it has a different name than the workflow for a regular scheduling a notebook. So I will show that in practice in a little bit. Whether it's a regular table or a streaming table, you still have that 3-level syntax for referencing that. The code is a little bit simpler. We still have this DLT reference to the old name in the code itself. You just define a DLT table and then or use this decorator DLT table first, and then you define what that is. And as you can see, you're kind of specifying more the read side, and then Lakeflow Declarative Pipelines handles everything else. So that is you can see that the code is a little bit more simple on this side than on this, like the pure structured streaming side. The Lakeflow Declarative Pipelines do build on the structured streaming capabilities. So functionality wise, they are quite similar to each other. With that covers the Databricks side. And let me just check whether there's anything in the chat. Any questions at this point? Yes, there is. From Andre, he asked, how would you handle duplicates with an append-only table? So either you would handle the duplicates in the stream code. So let me go back here. So if you're doing, for example, structured streaming, you would have it in between these two phases of the read stream and the write stream. That would be one option. Or if this is your kind of landing area and you're just getting the data in, you would just land the data and then handle the duplicates in the next stage. That would be one of the options. But yeah, we are able to also drop duplicates on the fly as well in a stream. So let's get back to where we were at. So then looking at the Fabric side of things, if we look at Fabric, we have also there are Spark capabilities in Fabric, so we could also use structured streaming there. But Fabric does have kind of this specific area that is meant for real-time processing, and it is called real-time intelligence. And what is at the core of real-time intelligence is event streams. And event stream is essentially a stream definition where you are specifying a data source, and then you are specifying what kind of transformations do you want to do that, and then you are pointing to a destination. And on the real-time processing side, Fabric actually has a specified, one could say, storage and compute combination that is meant for this time series data, where you have data that has kind of that time value, for example, some measurements, some IoT data coming in, telemetry, logs, etc. The event house structured is very much specified for that particular purpose. So it is very performant for querying that kind of data. Behind the scenes, Event House does use some of the OneLake storage as well. It uses it for cache and things like that, and for the older data, kind of the regular OneLake data side as well. Event House does structure the data in a specific way so that it is queryable in a performant way, even over time when the data amounts increase. We use KQL to query data in an Event House. So Event House is based on the technology that has been used in Azure for log analytics for a long time. And if you've been looking at log analytics and querying logs, you might have come across needing to write Custo query language. And it's a weird language because it does look like a little bit weird if you're used more to SQL and things like that, but there is a logic to it, just as with any query language. And it's, in the end, it's not that hard to learn, but it's just different than, I would say, like regular data processing languages in a way. And one of the things that you can do in Fabric side is that you can create a KQL query set, and that defines a set of KQL queries that are kind of those that would answer your core questions that you want to be able to answer from your data. I was just recently trying to figure out how to describe KQL query sets, and I couldn't quite figure out whether I would say it's like a collection of notebooks. If you're coming more from like the PySpark Databricks side, that maybe makes sense as a description. You kind of put a few notebooks together and they're kind of your, like, these are the core things I need to find out from my data. But then I think for SQL people, it could make sense to describe them a little bit more like almost like a stored procedure. Again, those are the ones that you can kind of, are the one set of queries that really contain the stuff that you need answers to continuously. So I don't think either one is like exactly right, but those give you some idea of what that means in practice. We also have real-time dashboards available in the Fabric side. That is not within Power BI, it's its own offering in the real-time intelligence side, and that is a dashboard that is really meant for if you need to have that data refresh all the time continuously. But you can still also have that data go to Power BI if you wish to combine that with other data as well. And of course, it's possible to use a lakehouse destination also from an event stream if you want to combine that to your more cool path of data processing on the Fabric side as well. If we look at the Fabric experience, it is a little bit more, I would say, drag and drop, how the whole UI looks. So it's easier to get started than the Databricks side, I would say. We will see this in practice as well in just a little bit. It is, as I mentioned in the beginning of talking about Fabric, it is possible to do structured streaming in Fabric as well. The concepts are almost similar. We can create notebooks within Fabric. Again, we specify in our code how are we connecting to our data source that we want to use. We use the exactly same syntax as we would use in Databricks, but within Fabric we have the Spark Compute available as this more packaged. You cannot go in and toggle the switches in any way to do this. So you have less control, but you can of course specify libraries and things like that. And then typically with notebooks, you would write to a lakehouse and write that data in there as a table. Something kind of you have to know from the Fabric side that at least at this point in time, you need to use a Spark job to schedule these structured streaming workflows. It doesn't quite work right in the kind of the regular pipeline side at the moment. We'll see if that changes over time. But it is possible to do that. It feels a little hacky and not as robust as on the Databricks side, but it does work. Something that is also a little different in the Fabric side is that we have this real-time hub, and this is kind of the central place where you can find all your streaming data sources specifically and event-based data assets as well. So that of course includes these event streams that you might create, but it also creates all the data sets that you have in event houses, as well as, for example, you could have events from Fabric that you want to react to, or events from Azure, etc. And as we can see there with the browse and preview tag there's the event schema registry here to exactly help with that schema evolution challenge that we sometimes have to handle when we are working with real-time data. But since we've been kind of covering this at the theory angle, I thought it might be a little bit useful to look at it in practice as well, and to actually get to like, what does this look like? But now that there's some theory in place, it will be easier to understand the practice as well. So let me just get the right window out here. So. So let's get the Teams control is coming in the way. All right, let's start from here. So let's go in the order in which we kind of started discussing these. I'm actually in the workspace that I set up for the demo today. There is serverless compute available nowadays in Databricks. It has to be turned on. It is not on by default. But it's kind of that same approach to clusters as we have on the Fabric side. You don't have to do anything, it's available there. All the core libraries that you need are available by default. And then of course you could get some additional ones configured as well. So in this first cell, I'm just configuring some of the core variables that I'm gonna need. So Databricks actually has a set of cool data assets and sample data sets that you can use, because one of the challenges with streaming data, it's actually quite difficult to find data sets that you could use to play with them. And if you don't have any experience with streaming data, it's quite hard to jump into real data right away. But Databricks does have these streaming assets that you can use. So in a Databricks workspace, you get to just reference it directly. They are under the Databricks datasets path, and you can find a few samples there. I'm gonna create an events table, and then I'm specifying a location to the raw catalog. So I will show that in a moment. I have a raw catalog with a streaming schema, and then I'm creating an events table under there. And then I'm specifying a checkpoint path, which this is a storage account within Azure that I have created, where I can then have the desired structures for my data. So there we go. I have a raw and clean container here at the moment. So let's start there. Let's run that. And since this is the file path that I'm using, it's not Kafka or anything like that. So in this case, I need to use this Cloud Files Format option. And then the other options for that we can use is there is a JSON, a format specifier in the sense of like, is this JSON or CSV, etc. And then you can set a schema location path and then the actual file path of where does it read it. And then I'm going to select all the columns, add some metadata columns as well, and then write this to my location where I want it. So I'm using the raw catalog location with the 3-level syntax that I specified here. So let's see. What you will notice here, I have the append output mode. That means that this table could be used consequently also as a streaming source. And then the other important aspect here is the trigger. I'm using the available now, so it means that it will start the stream, read the data, and then stop it. I could have also like a continuous mode, then it would keep that stream running. And that of course means that the compute that is running that stream has to be on all the time, which of course then can have cost considerations that we need to take into account. So if we look at this, we can see our data. Input rows 0. Oh, that looks very, very lovely. No, there we go. Sorry, 100,000. Okay, that's actually quite nice. The rows per second is a really nice low amount as well. When you're doing append and not really any transformations, that's of course the case oftentimes. So if we now go to our catalog, I have my raw catalog that has a streaming schema. I can see my events table. I can see all the different columns that I have available. And then I need to select a compute to be able to view the sample data. So it'll show me like a snapshot of what's in my table. It will take a little bit for the serverless to start up. So I can see the data that I got in. I have to say, it's not maybe the most interesting data set, but you know, sometimes, for example, from a sensor or something like that, we could get data like this. So you, for example, get the whether a door is open or closed or something like that type of status. So in some cases, the streaming data is very, very simple, but just wanted to have different kind of samples for the different things I'm using today. So that's why this one is a little bit maybe a dull from the data perspective. So if we look at the I want to say Delta Live tables, but that's not what it's called. The Lakeflow declarative pipelines is what I need to call it. I will start from here. So we have jobs and pipelines. This is kind of the workflow section of Databricks. We can have like a regular job. This is where you just specify your notebook. So if I wanted to, for example, create a pipeline for the event ingestion that I just showed, I would just do that here and then specify like, hey, what is the notebook that I want to run here? So I'm gonna use workspace, and then I'm gonna find my notebook. Sorry, there we go. And that's it. Then I get to specify like what compute am I running this on. You could have also the source as a Git provider. So if your code is in GitHub or Azure DevOps, then it's easy to link there as well. So that's it. That was creating a pipeline. Of course, a lot of times our pipeline might have multiple notebooks, and it's more of these steps in one, but the process itself is very, very simple. And then I could schedule this according to what I need here. But the other side that we looked at in the slides is the declarative pipelines, Lakeflow declarative pipelines. And they are somehow called, as I mentioned, ETL pipelines here. So I will just show you quickly what the process is when you start. So you give it a name, you specify where does this live, so to speak. It can be just the default location. The data still can have a different target, but for example, I could start with that. And you can either start with sample code in SQL or Python. You can start with an empty file, or you could link to some files that are already in your Databricks workspace. Or of course, you could have this way of using Databricks asset bundles, which is like a definition that includes your code and then also the artifacts that you are creating within here in Databricks. Behind the scenes, kind of the creation of pipelines and things like that it contains actually uses Terraform. It's just packaged into a different syntax. I could start with some sample Python code, so it will create me some sample things that I could use here. But I will show actually the pipeline that I had prepared beforehand. So let's go back here because it's a little bit more manageable than the sample I had there. And this I have run already before, but let's look at the source code itself. I have to say I don't like the layout of this thing because it's, as you can see, it's like too much information in one go. Especially if you're using just one screen, it's hard to manage. So what I could also do is I could go to my workspace here and just navigate to my folder where that file is specifically. Oh, it used to open it as a regular file and didn't show the other window. Well, that has changed. Too bad. Let's make it as big as possible. So it looks like a similar kind of notebook that we had, but these you can actually just run in the context of like being in the pipeline. It doesn't run as a regular notebook so nicely. There are some ways to kind of troubleshoot it there, but mainly you would work with them on the pipeline side. Again, we can have some imports as in a regular notebook. We can have a path defined. I'm using, again, a different sample data set that is available. Then we can define a schema if we want to ensure that everything is typed correctly. And then we are defining a table and then the actual definition that writes to that table. There is currently like different syntaxes that are supported for these definitions a little bit, but this is one of the samples. So again, this is like we're doing a similar thing as I just did in the streaming notebook, but as you can see, the syntax is a little more simple. So this is kind of equivalent to what I showed in the other notebook. So it's a few less lines in this case. Again, I'm using the cloud files format. I'm specifying the schema. This particular file is CSV, and then I'm specifying the separator and then where the files can be found. And from there, I am then able to write it in the right place. It is the schema value here that specifies what is the structure of the data that I am writing. And then you have this option of defining materialized views that are kind of, in this context, they are like temporary views that you can use, that can be used within this particular pipeline. So those are there. And then this shows up as a pipeline where I can see like what has happened in each of these steps. And I could also be able to run each of these separately and specify, kind of check, is it doing the right thing? So, and then the kind of running of the pipeline is simple. It's a click of a button, and you can of course have these scheduled the same way as we would have like a regular pipeline as well. And then it will keep track of this. So the function of these declarative pipelines is that it simplifies the syntax compared to like regular structured streaming. It also abstracts away the checkpointing that we had to do in structured streaming, but otherwise it functions very, very similarly. That's kind of the main difference of like what you need to consider here. And if I look into my catalog, because I had my catalog specified, I am in raw, and then I had this song side, I can see that the materialized views are here, as well as the raw table. This is, here you can see the difference that this is a streaming table. It has the little waves there. It was that definition that I did. So by default, if you don't specify any kind of other location where you want your data to end up, they will end up in this schema that you specified for this particular configuration when you started it. But you would have the option to also like, hey, read from the raw and write somewhere else. But as you can see, there's still, I think, quite a bit of code involved in this as well. It's not, you know, click and drag, but there's the UI that tries to help you understand what is happening in the pipeline and make it a little bit easier for us to manage in that way. But if we come to the Fabric side, we have a Fabric workspace that is in this case linked to a trial, Fabric trial in this case, so we can also play with the streaming on the trial capacity. The core capability for doing real-time things in Fabric is definitely the event stream, because that way you get your incoming data to be nicely in this management view where you can have the source and the transformations and the destinations. So this is very much the core. So when you start, you have kind of these few options there and a few here, but if you go to connect data sources, you actually find the full list of supported sources, and you need to still click view all. And when you come here, you can actually see there is a lot of supported things. And I would say there's kind of like different types of events or streams you can connect to. So there's like these event broker type services like Event Hub, and then the Amazon versions like Kinesis and the hosted Kafka there. There's some general ones like Kafka and MQTT as well. But then we have databases with CDC. We can also connect directly to an Azure Data Explorer instance, or we could grab events like what happened type of events from Azure or Fabric. And then we also have like, we can connect to an HTTP endpoint. So the variety of supported sources that we could use for streaming is starting to be quite big. And how it works for us is that, well, I will, for today's purpose, since it's quite a lot of stuff to fit into an hour, I will use the sample data set that is available. There's a few different sample data sets here. Note that the yellow taxi and stock market, there's quite a lot of data that comes in, so it will put a bigger load on your capacity. I'll take the bicycles the sample data set here as well. So I end up with this nice view of the different steps that I have in my event stream. We'll wait for a bit for the first set of data to show up here. So the nice thing is that I can kind of see live, like what is the data like, what are the columns that are there. I don't like have to run yet anything to get this visibility to the data, but right when I'm connected, I can see live what the data is like. So that is kind of the stream itself. And then I have a few aggregations here that I could do. So I can, for example, like choose specific columns. I can do grouping, I can do filtering, etc. And then the newest addition is actually that we can also write SQL code to do a transformation on our data. But let's grab an aggregate. It still confuses me that it shows an error right away. Like just open the editing window so I can just make the editing that I want. So let's see. So these are like bike stations in different neighborhoods. And let's say I want to find where are the maximum number of empty docks there. And then I want to look at that by neighborhood. And then I choose this particular one is like it's looked over some time period. So let's say I need to set this low enough so that we start to see data at some point, and we don't have to wait for a long time. So then, oops, I want to click the plus, and I get to choose where does this data end up. So I'm gonna say, in this case, let's use an event house. And luckily, I can now create an event house here on the fly because I always forget to prep it beforehand. And it will offer me like a default name for the KQL database. So I think I saw a question in the chat as well in regards to this, that is event house a KQL database? So event house is like a collection of KQL databases. So you can have multiple KQL databases within one event house. So I would almost think of the event house like as a database instance, I guess, and then you have the specific databases under it. And there is like some default settings for retention and things like that. But then you can also yourself specify those, like how much data do you want to be stored in the cache itself, and then and that will determine how much data is like in the hot storage and how much is in the cooler storage tier, and that will of course affect how much cost you will have. Yes, Andre is right. He's writing in the chat there. So let's create a table. I need to click the create new because I don't have that table. And then I can specify what is my input data format. And this particular one is JSON. So if I start the data preview, I should be able to see the data live. Sometimes it takes a moment to refresh. So let's see how it is today, whether it will allow me to see it on the fly nicely. So here then I can see like, hey, I have my new column that I specified. Since it's like a maximum number of empty docks, it will have all the neighborhoods with the same value in the same time window will have the same number there, since that is what I specified. And then of course I could have done grouping and things like that to make the data a little more sophisticated than it is at the moment. But that is the core idea. So you have this nice click and drag experience. You can have multiple sources. We had that joint transformation there as well to help with that, how you have to join them then. You can have multiple different destinations that you're landing your data in. And then I think that SQL transformation option is also very powerful and useful for being able to have like a little bit of variability in what you can do, because always with built-in transformations, you land into situations where you're like, oh, I can't quite do what I'm trying to do. And having that SQL option there is very, very helpful. So at this point, when I'm just like editing this is not yet published or like running properly continuously. I need to publish it. And then I always have the option that, is this actually activated? Is this deactivated? What is the status there? It will take a little bit of time before the data lands in the event house. So I will leave this to run here, and let's go pop into the real-time hub really quickly in a little bit. So it has now started. I can be sure of that. It will take a little while before the data lands in the event house because I had that windowing function there. And the real-time hub is really that place where you can come and see the data that you might have in your different workspaces. This is also where you are able to add those different sources that we could also start with from the event stream. So this is also kind of one of the places where we can start from. You can find both the supported data sources as well as the sample data sets. And that way you can kind of register them in the real-time hub to be visible. Just like maybe a quick note about the Fabric events, because of course we are within Fabric, we probably want to take some actions on things that happen within a Fabric. So at the moment, we have the workspace item events, so things created, things modified, etc. We have OneLake events, so files, folders created, modified, deleted, etc. That kind of things. And then job events are like the status changes in jobs, like pipeline runs or scheduled notebooks. A run started, a run failed, succeeded, etc. That kind of events. There's also the previews for the capacity overview and anomaly detection events as well. So those will be interesting to see what they provide to going forward. So let's see if the data has landed here. So this is the event house itself, and this is the KQL database within it. If I go to the event house, then I can see a list of the KQL databases that are there. I can see how much storage overall is in my event house. And for me, that windowing function that I was talking about, like if I make that too big, it will take us like 15 minutes to get any data here. And I hope, yes, just in time, we've gotten some data into our table actually and landed here in the event house. And then we have the options of starting with a dashboard or creating a Power BI report based off of this, or even reading it from a notebook as well. And kind of the important factor is do you want that data to then also land in OneLake? By default, that is off, and you could turn it on if you that desire. So then it will also kind of land it there as well. I think we are starting to run out of time, so I need to wrap this up and return to our slides and get to the end. Luckily, I am where I'm supposed to be in my slides and not somewhere else. This brings us to the kind of the recap. How do we actually compare these different tools? And when would you use which? With both, we are able to do similar things. We are actually able to run structured streaming in both of them. It is a little bit more flexible on the Databricks side, to be honest, and it's just a more intuitive developer experience there as well, but it is possible in both. Why is my slide not changing? There we go. On the Databricks side, as with all of these data platforms, it seems that there's always coming things that try to make our life easier. And here I've forgotten to change the text. They are the Lakeflow declarative pipelines nowadays, not Delta Live tables, but kind of the bringing the ease of use to this really powerful capability that we have and bringing it more closer to the point where you don't need quite as much coding experience. In the Fabric side, we have the real-time intelligence, and it is very much has that, any user could use this and get going. Hopefully, those users do kind of understand the implications of real-time processing, but it does bring that aspect that you don't actually need any coding experience to get going. So what is, I feel like, the best strength of Databricks is that there's a lot of robust orchestration and good visibility to that, both on the structured streaming and Delta Live tables, Lakehouse declarative pipeline side. And then on the Fabric side, you have that real-time hub and that, business-friendly user experience there as well, where it does bring it more, it's that these things are available to a broader range of users than they would be in the Databricks side. So I think those are kind of the highlights from each. Databricks is really robust, can run everything in whichever mode you want to. You have all the toggles depending on which version you go with. With Fabric, you definitely have that ease of use and data discoverability, and thinking of your streaming data sets also as data assets, like a regular table in a lakehouse, for example. So what should you take away from this session? We walked through the streaming consideration, what are the different capabilities in each of these tools and kind of how they compare to each other. Yes, streaming is hard, but luckily we're starting to have these capabilities that make it a little bit easier. So use it when you need it, and when you really have that requirement that, yes, you need those answers right away. And then use the tools that make it easy for you, well, as easy as possible. If you have more requirements for having more control, then you probably will lean a little bit more towards the Databricks side. If you are going more towards yes, you are fine with the transformations that are available and you can work with the capabilities that are in Fabric, then you might be leaning more towards Fabric as well. But always, of course, remember to take into account the whole architecture and what tools are you using otherwise as well, because that, of course, always plays to the game as well. But with that, I hope you learned something new and have some ideas of what to think about going forward. Thank you so much for joining. You can find me on LinkedIn, and no, you cannot really find me on the old Twitter again. You can find me on Blue Sky nowadays. And please leave me some feedback. First time I'm doing this particular session in this format. I've done it previously in a very different style, so let me know if it's going the right way and what I can improve on. Thank you so much for joining. I'll stick around to see if there's any questions left, but I think officially we have to finish so the next person can come on. Thank you, everyone.